Yeah.
Hello everyone, this is your best friend, Gabuya. In this video we will be exploring two rules of probability, which is the conditional rule and complement rule. Let's tackle first about conditional probability, to which it is the probability of an event occurring based on a previous event already taking place. If A and B are two events, then the conditional probability of A given B is written as P of A vertical bar B. When we want the probability of an event from a conditional distribution, we write P, B vertical bar A, and pronounce it the probability of B given A. In this video, I have shown two ways of its formulas such as probability of A given B and probability of B given A. The formula can be read as the probability of the intersection of A and B over the probability of B. Note: the denominator cannot be equal to 0, since we know that it has already occurred. And the given will always be the denominator. In solving real-life problems or in word problems, conditional probabilities are usually be recognized by words such as given, if, or among. Let's read the first example. An octahedral die, a die with 8 faces, numbered 1 to 8 is tossed. What is the probability that the number turns up to be odd given that it is less than 5? As seen in the problem, there is a clue word, given, that indicates conditional probability. Now let's try to answer it. Let's identify first the given. Event outcome of A, which is getting an odd number, is equal to the numbers 1, 3, 5, and 7, and the number of event outcomes of A is equal to 4. And then for event outcomes of B, the numbers which is less than 5, so these are the numbers 4, 3, 2 and 1. So event outcome of B is equal to 4, since there are 4 numbers in an octahedral die which is less than 5. And then we will be looking for the intersection of A and B, to which we just need to look on the event A and event B, and find which of the numbers occurred in both events, and those numbers are 1 and 3. Now we have the intersection of A and B which is 1 and 3, therefore the outcomes of A intersection B is equal to 2. After we have identified the given, we will now proceed by using the formula of conditional probability. Probability of A given B is equal to probability of the intersection of A and B over the probability of B, and then we will be substituting the corresponding value. Event outcomes of A intersection B is equal to 2, then over the total number of sample space. We all know that in an octahedral die there are 8 faces, therefore there are 8 numbers in the sample space, making this 2 over 8. Next we have the event outcomes of B equal to 4 over 8, which is the sample space. And then we will be simplifying this one, resulting to 1 over 4 divided by 1 over 2. Then our final answer would be 1/2 or 50% is the probability that the number turns up to be odd, given that it is less than 5 in an octahedral die. Let's try another example. The probability of rain on a certain day and Tom being absent is 0.3. The probability of rain is 0.4. What is the probability that Tom is absent, given that it rains? In this problem there are 2 events, which is Tom being absent and the rain. Our event, A, would be the probability of rain, which is 0.4. However, in our event B, which is the probability of Tom being absent, is not presented. But the intersection of B and A, which is probability of rain on a certain day, and Tom being absent, is presented, which is 0.3. This given is enough to substitute in our formula. The formula to be used is probability of B given A is equal to the probability of the intersection of B and A over the probability of A. Now let's substitute the corresponding values. Probability of B given A is equal to 0.3 over the probability of A, which is 0.4. To which our answer is 0.75, or 75%, is the probability that Tom is absent, given that it rains. Now let us move on to the complement rule. In statistics, The complement rule is a theorem that provides a connection between the probability of an event and the probability of the complement of the event, in such a way that if we know one of these probabilities, then we automatically know the other. The concept of this rule is that the events of one outcome happening and the outcomes that are not happening are complementary. Now let's derive the formula of the complement rule in these statements. The complement A of the event A consists of all elements of the sample space that are not in A. The complement rule states that the sum of the probabilities of an event and its complement must be equal to 1. The formula would be probability of A plus the probability of the complement of A is equal to 1. In solving real-life problems or in word problems, complement probabilities can usually be recognized by a keyword, not. Let us examine this example. If you pull a random card from a deck of playing cards, what is the probability that it is not a heart? It has the keyword not, indicating complement rule must be use. Now let us answer that example. Our given would be, event A would be the heart, and event complement of A be the event that it is not a heart. Let us move forward to our solution. The formula would be probability of A plus the probability of the complement of A is equal to 1. Then, we will derive it as probability of not heart equal to 1 minus probability of pulling a heart. As you can see in the image, there are 13 clubs, 13 spades, 13 hearts, and 13 diamonds in total of 52 cards. So the probability of picking a heart is 13 over the total of cards, which is 52. Substituting to our formula would be 1 minus 13 over 52. Simplifying it to 1 minus 1/4. So the probability of pulling a card that it is not a heart is 3/4 or 75%. Thank you for watching, and that would be all for this video. If you have any questions, just send me a message to these accounts and links. See you.
내가 만든 쿠키